Okay, so in number 7 on the practice worksheet, we're asked to graph this function without a calculator, labeling 2 anchor points, coordinates, and dashing in the asymptote. So 3 is the A value, and then 2 is the B, the base. The H, since this is x plus 2, that's the same as x minus a negative 2, so my h is negative, and the graph goes to the left. And then the k is a minus 1. Okay, so the growth or decay is based on the base of the parent function, and that's a 2. 2 is greater than 1, and so this will be exponential growth. Okay, the domain of all exponential functions is negative infinity to positive infinity. Okay, the range is based on whether or not there's been a reflection and the k value, that horizontal asymptote. So since there is no reflection, the a is positive, the range is starting at that horizontal asymptote of -1, and it's headed up to positive infinity. The asymptote is that k value, so y equals -1 will be my horizontal asymptote. And so I can come over here to the graph and dash in that line, y equals -1 for my horizontal asymptote. Okay, now the transformations are based on the anchor points for the parent graph. And my parent graph is y equals 2 to the x power. That's going to pass through 0, 1, 1, b, and the b is a 2. And then -1, the reciprocal of b, and the reciprocal of 2 is 1/2. Okay, then we multiply the y value by the a, and our a is 3. So we multiply each y coordinate of the anchor points by a equals 3. So we'll have 0, and then 1 times 3 is 3. Then we have 1, and 2 times 3 is 6. Then -1, and 1/2 times 3 is 3/2. Okay, then we're going to apply our horizontal translation with the h, and we do that by adding h, which is -2, to the x of our coordinate. So 0 plus -2 is -2. Then 1 plus -2 is -1. And -1 plus -2 is -3. Okay, next we're going to take care of our vertical translation, which is going to move all these points down 1. And we accomplish that by adding the k, which is -1, to the y coordinate of each of these points. So our x stays the same, and then 3 plus -1 is 2. The x stays the same, and 6 plus -1 is 5. And then the x stays the same, and 3/2 plus -1 is 1/2. So we'll come over to our coordinate plane and plot these points at -2, +2, -1, 5, and then -3, 1/2. Now we can see that we need to find some additional guide points to help us figure out how to bend across this, this curve. One of them that would be useful would be knowing the y-intercept. So I'm going to go ahead and put 0 in for my x, and then evaluate evaluate this function. So 3 times 2 raised to the 0 plus 2 and then minus 1 would be 3 times 2 squared, which is 12, and then 12 minus 1 is 11. So the point 0, 11 would be my y-intercept. And then I can tell that this is going to head off the graph pretty much immediately. So coming the other direction, let's try -4 for the x, since I already know -3. So that would be 3 times 2 raised to the -4 plus 2 power minus 1. So 2 to the -2 is 1/4. And times 3 would be 3/4 minus 1, which is 4/4, and 3/4 minus 4/4 is a -1/4. So at -4, we're right underneath of the x-axis at -1/4. And then that gives me enough information to come along this horizontal asymptote, and then we're going to bend through those guide points and then the y-intercept and up to positive infinity.